Hello student, in this video I'm going to discuss about modeling and a few other important topics of animation. I'm continuing the same material from the last one. Uh, Modeling, that is actually while creating an animation in animation software, you need to create some models. There are various ways to create the masses on a computer. In order to create a complex masses, it can be often digitized. More often, however, one has to model the mass. Modeling is the process of creating 3D objects from simple 2D objects by lofting. Lofting means just pulling some parts of the 2D objects to create like 3D objects or form other simple 3D objects called primitives. There are some primitive 3D objects might be available in different animated software. Primitives can be combined using a variety of Boolean operation. They can also be distorted by dragging around their vertices or distorted in different ways using different mathematical process. You can apply boolean type of operations also. You can use various drag and drop options available in the various animation software. Like in Blender also, there are various functions available to create the or to manipulate the 3D objects, to manipulate the primitive 3D objects by pulling the vertices or by pushing the vertices in a specific way. Like you can pull the objects, pull the vertices in a definite pattern. The pattern are available in the software. It might be available in the software depending on the software variety. Specifically, here you can see a mesh. Mesh is a collection of faces which describes an objects, and objects can be anything. It might be sphere, pyramid, cylinder, tire, elephant, and it might be anything which is available in that specific animation software. The faces are arranged in such a way that they form the outside surface of that object. So here you can see this sphere mass, the mass of sphere, where every face, every polygon will contribute to create the sphere, and actually this is the surface part of that sphere. So it could be thought of as a skin of the object. The mass is usually depicted in wireframe. So this is actually wireframe in raw term. That is wireframe mode, as this shows the faces and outline of, and does not take very long to render. So to render this type of objects takes less time in the animation software. There are various other ways to do the animation. Like here you can see one object oriented graphics. There are two kinds of computer graphics. One is bitmap, and another is object oriented. Bitmap is, you know, that which follows a pixel oriented approach, but in case of object oriented, it will be specific program oriented. You create object oriented graphics in a drawing program. When you create objects in a drawing program, you can still edit them after you have done something else. For example, if you draw a circle in one place, then draw a rectangle in another place, you can still select the circle and change its size and locations. So this is possible because object oriented graphics are stored as dimension and formulas, unlike the bitmap graphics which are stored as individual pixels. So you can find out the difference between these two. Bitmap graphics are usually pixel oriented, but object oriented graphics are more function oriented, or because that is why we can add, delete, or manipulate the dimension using different formulas. Like that, when a drawing program opens a drawing file, it looks for an objects, not pixel. In case of object oriented graphics, a drawing file may be thought of as a series of instructions like the ones below, but in a computer language which most normal people cannot understand. So here you can see one statement: draw a circle at the point that is 100 pixels to the right and 100 pixels down from the top left center of the screen with radius of 25 pixels. There are advantages as well as disadvantages to that object oriented graphics over bitmap graphics. As already mentioned, the object oriented uh, object oriented graphics can still be modified as separate objects after being modified, unlike bitmap which cannot. Second, object-oriented graphic files are usually much smaller in size than bitmap graphics. Third, you can enlarge the object-oriented graphics at any size and it will not lose detail. That is because most object-oriented graphics are resolution independent. That is very, very important in case of object-oriented graphics system, which is resolution independent. A disadvantage is that they are usually harder to create and cannot have many interesting special effects done to them, such as blurring. For example, you cannot go for more because in object oriented pixel we do not apply the effects on pixels. That is why we cannot directly blur any pixel, or we cannot directly blur any part of an object. So that is why we cannot directly give some special effects. But in different animated software, along with the object oriented approach, there are specific applications or there are specific functions to apply those effects also. So that is why there is difference between object oriented graphics and bitmap graphics, and there are disadvantages in both or advantages for both of them, and that is why we need to understand both and in any animation we might need to use both ideas. In regard to 3D modeling, there are three primary operations of Boolean operations like addition, subtraction, and intersections. In order to create a Boolean object, you first need two other objects. They can be primitive or other masses. They also need to be intersecting 3D space. If you do addition, the resulting object will be sum of the initial object. It will look like as if two were welded, means two are joined. If subtraction is what you are doing, the object gets subtracted from the first one. A hole in the shape of the second object is created in the first one, and all the spaces that is occupied by the both of the object is taken away from the first one. Finally, the intersection mode, the final object occupies the area in which both the initial intersection intersected. So here you can see these two objects are here, two original objects. One is the cylindrical shape, one is spherical shape, and when you add them, it will create like just welded the objects like this way. But if you subtract them, this is the first object, this is the second object, so the part which are common for both of them will be minus, meaning deleted or subtracted from the first one. This is subtraction. And in case of intersection, only the common part, means which are the intersection part, will be kept. That is intersection of two objects. So these three are basic or primary operation in 3D modeling, Boolean operation. Contouring is the loss of detail when you converting a gradient image into an image with a smaller number of colors. So here you can see this is original sphere, and this is the contouring effect, where you try to use lesser number of shading with specific layers. So contouring is the loss of detail. So here in this original sphere there are lots of details, very minute details are there, but in case of this one, this is in this contouring affected sphere, we have a less amount of detail and smaller number of colors. That is how we can do the, or that is the way we can do the contouring, or that is the contouring effect. So in real life we can tell where objects are being by measuring distance between them. Objects are by measuring distance between them. As for placing them, moving them, and keeping track of where they are, NASA has developed a pretty good system. On computer though, we have to somehow keep track of object in 3D scene. Mathematics have developed the coordinate system. You have probably learned in geometry about the x and y axis. Well, these two axes define a coordinate plane, that is two-dimensional world. However, to work in 3 dimensions, we need we need one more axis, that is z axis. We know that its axis is like a number line. The three axes are perpendicular to each other. The point at which they intersect is called the point of origin. The point of origin designated as 0, 0, 0 because they're located on the 0 point all the three axes. Now let's say that you want to define point in space. You can do this by giving it three numbers. The first one, the distance of the point from the origin in the x-axis. Second one is the offset of the point from the point of the origin along the y-axis, and the third one in the point distance away from 0 along the z-axis. So this we know these things as from the mathematics point of view also, what is 3D system, what is 2D Cartesian system. In case of digitizing is the process of converting continuous signal into distinct units that the computer or our electronic equipment can process. There are many ways to digitize things. There is microphone which digitizes sound. The scanner can digitize photos and other images. A digital camera is able to bring video into the computer. You can also digitize 3D objects. For that you use a 3D digitizer. These come in many different shapes and sizes. They usually use laser to map out the 3D points and create a mesh. In case of 3D printing also this is used. Some other ones may use a pen as a probe which is attached to some sort of armature which can calculate points you touch on real objects into a computer model. So there are more few topics, important topics are here in this material. Through this material we'll just able to get some basic idea about different items or different names and different terminology regarding animation. I'll try to cover them within few in the other videos, next videos. So till then, if you have any confusion or any question need to be asked, then please ask. And also if you want to add something more, then also add. We'll try to resolve all those things over Google Meet. Till then, thank you.